So I'm going to give a little background here. First, I guess that's some context for the day on sort of why we're here, what brings us together, and I talk a little about Hadoop, which is an underpinning of a lot of the technology and things you're going to hear about. So first up, some context. So we've seen this unprecedented thing in technology over the last 30 or so years. If you look at this graph here of transistors in Intel CPUs, it's a nice, pretty upward and to the right graph, which is what we like to see. But it's the crazy thing about it is the scale. It's an exponential scale. We've seen 10,000-fold growth in the number of transistors in a processor, and correspondingly in the size of hard drives, the speeds of processors have gone up tremendously. All of these aspects of computation have been improving dramatically. And we kind of in the industry have taken that for granted for a long time. And we shouldn't. It's phenomenal. We don't see this anywhere else. You don't see this in transportation. We can travel a little faster than we used to, but not 10,000 times faster. We can't get anywhere in the world in seconds. You don't see it in architecture. Our houses are not 10,000 times bigger than they were 30 years ago. Some people have a little bigger houses, but a lot of us don't. So this change has really not been well reflected in the software that we use to process data. It's been reflected in some technologies. We see a lot of this mobile technology. This is 1,000 times the technology you could carry in your pocket, I think, 30 years ago. But in data centers, I think we've seen some lag. I think the software systems, the design didn't evolve apace. And so we're presented with this opportunity to have a new approach. And that's the approach we've seen arrive. It's a new approach to using hardware. I get here. There we are. So instead of the more traditional approach of using exotic hardware, having some large centralized servers that are very expensive, special networking systems, special storage systems, instead we use commodity hardware. We use racks and racks of things that are much the same as the hardware that's in desktop PCs, the most widely produced hardware that's out there, because that's going to give us the sort of price performance that we want. We use, again, commodity networking. We don't use a RAID, we use just a bunch of disks. Instead of trying to build reliable hardware and build reliability in at that level, we accept that the hardware is unreliable and try to build the reliability in at the software level. And so consequently, we get systems which are much more cost effective. You can store and process, in many cases, 10 times the amount of data at 10 times the rates you can for the same amount of investment. And moreover, and more importantly in a lot of cases, these kinds of designs let you scale much further. You can simply analyze more data, which gives you more value. So on the software, we've seen a similar revolution in approach. Rather than having monolithic services, storage, and database systems, we instead try to distribute everything, is the new way of doing things. So that we have lots of these little nodes, each of them themselves doing computation and storing data, not fully independently. They need to coordinate, and that's what the software helps to do. Another big distinction is the strategy of storing data raw as it arrives. In a database system, people spend a lot of time designing schemas up front, so that they project all their data into these schemas as they store it. And oftentimes, it's over time they'll want to change that, and it's very difficult. And rather, if storage is cheap, you can save all the data as it exists originally, and then project schemas onto it dynamically as you wish. You can save that if you like or not. And it's a much more flexible approach and allows you to reinterpret data in different contexts and get more use out of it. Lastly, I think the new software we're seeing tends to be open source, whereas the previous generation tended to be proprietary. And I think this is a a big distinction I'm going to talk a little bit more about in a minute. First, I want to mention that we've got this ecosystem of projects. We've got Hadoop, which I think of as very much like the kernel. It handles storage and resource allocation and scheduling, authorization, authentication, these kinds of issues that are classically operating system issues. And it's becoming this kernel of an industry standard system for distributed data processing. But nobody uses the kernel alone, just like in Linux. You can't just install a Linux kernel. You install a suite of things around it. And we have yet to run into anybody who uses the Hadoop kernel alone. Everybody installs some other elements of the ecosystem: Pig, Hive, HBase, Flume, Oozie, Scoop. There's all these different projects, which you'll probably hear more about as you're here. And almost all of these are projects at the Apache Software Foundation. So I'm going to talk a little about Apache and why I think Apache provides a really strong foundation for this ecosystem. Apache is a nonprofit organization, hosts about 100 different projects. It's something of an unusual organization in that it doesn't really have a strategic agenda. Apache's organizational structure tries to promote healthy communities and healthy interactions around software development, and doesn't mandate any particular kind of software. You can bring any kind of software project to Apache. And at the top level, we don't care about the quality of the software even, or whether anybody uses it. What we find, though, is that quality and use are emergent properties when you have a healthy community. If people are collaborating, they tend to collaborating from diverse institutions in a transparent manner. That tends to attract more people. It tends to attract projects that are actually useful and that create high quality code. Some other things about Apache: it allows competing projects. So we've got both Pig and Hive, which have a lot of similar functionality. And Apache doesn't have to pick a winner. We can let the market pick a winner, or let them both succeed and progress, because they have slightly different advantages in each case. So it's also a loose federation of projects. We're not building this tightly integrated system. We've got all these components, and no one of them is necessarily critical. I mean, I described Hadoop as a kernel, but you could replace Hadoop. You could replace the file system, and the ecosystem would survive. And I think that's a really strong argument for this ecosystem, that nothing is sacred when you've built things this way. Lastly, it's a great comfort to users to know that the software is available for free, that they can get involved in the projects if they want to take it in a new direction, because they know there's not some vendor out there who might start jacking up the prices or moving the project in a direction they don't like, or discontinuing features that they do rely on. And I think people find this very comfortable, and it's led to a lot of the popularity of this platform. So I want to start to wrap up by talking about how people use Hadoop. We've seen this pattern many times. I think it's roughly the pattern that Google, when they first developed a lot of the underlying technologies, followed. It's certainly the pattern followed at Yahoo, and at Cloudera we see it at customer after customer. They have some problem where they have that is intractable, that they just can't solve using other systems. They try and they fall over before they can get the data loaded or complete the computation they have in mind. So then they try Hadoop, they build a proof of concept, and they find it works for them, hopefully. And they then start moving that into production, but in parallel, other people see this within the organization, and they start adding more data sets and more ideas in, and it ends up snowballing, and more of the company's data processing moves into Hadoop. We saw it, so at Yahoo, the initial example was search, web search. And before the web search even got launched on top of Hadoop, Yahoo was already doing lots of other things with Hadoop. And then now, they don't even do web search at Yahoo, yet they're still growing their use of Hadoop and using it in hundreds of places. They say every page view at Yahoo has several Hadoop applications hiding behind it. So finally, I want to ask you all to ask yourselves what this means to you. I think there's a real opportunity here. There's technology you can take advantage of. There's data that you've probably been ignoring because you haven't been able to store it and process it. There's data that your friends and neighbors may have that you might be able to use better and combine with your data to get a lot of insights. And I think you'd be remiss if you didn't think a little about what applications you can build to take advantage of this ecosystem that's developed. Thank you.